Hello there, and then welcome to a brand new lesson. Now, I do hope you are doing well. In this video, we are looking at the rationalizing binomial sets. In the previous one, we actually looked at how to rationalize the monomial set. That is when you have the denominator and it's just a term. Now, you'd realize that if you have a fraction such as 1 over, so 1 over a, then plus root b. If we were to rationalize and then we were to multiply this by root b, we are not going to get a rational number as the denominator, right? You can try it out. And if you were to try it out, this is what you are going to get. So because this a multiplies the root b, we'll get a root b, and then root b times root b will give us b. The main reason why we wanted to do this was to get a rational denominator. But this you see here is irrational because of this over here. Hence, if you were to rationalize a binomial set, we say that we multiply it by its conjugate. And for binomial set, if you have a plus b, if this was to be a set, then its conjugate is what? A minus b. And on the other hand, if you have a minus b, and then this was to be a set, then its conjugate is going to be an a, then plus b. What does this mean? If we have the root of x minus y, and we wanted to rationalize this, all we have to do now is to multiply it by its conjugate. So we are saying that we just write root of x. Then instead of the minus here, we make it as what? Plus. So plus y. And doing our multiplication, we have root x times root x, which gives us an x. Root x times y will give us positive y root x. Then negative y times root x will give us negative y root x. And then negative y times y gives us a negative y squared. With that, you realize that all you have in here is going to be eliminated because you have a plus and then a minus. So that we have x minus y squared. This is what is going to be our resultant. And you realize that we now actually have a rational what number. Let's look at what this means in practice. So with the little knowledge gained, let's see if we can try and then answer what we have here. It says we have to evaluate 6 over root 7 plus 1. And as we can see, your denominator is irrational. It is not a monomial, but it's a what? A binomial. There are two things. So what we need to do now is to multiply the numerator by the conjugate of this. And we are saying that the conjugate of a binomial is the same thing, but then we change the sign, you see. So we are going to multiply it by the square root of 7 minus 1. Then you have all over root of 7 plus 1, and then root of 7 minus 1. I do hope you know where all these numbers are coming from. So with that said, now we would have to multiply the 6 by root of 7 and then 6 by 1. We are distributing it over here. Then 7 times root of, that is root 7 times root 7, then root 7 times negative 1, 1 times root 7, then 1 times negative 1. And if you have to do that, 6 times root 7 gives us 6 root 7. Then we have minus 6 times negative 1, which gives us a negative 6. All over root 7 times root 7 will give us root 7 all squared. Now, as time goes on, we wouldn't be writing all of this again because we know that this square root will cancel out the squared over here and it will give us just 7. Okay. Then we have root 7 times negative 1, which gives us negative root 7. Then 1 times root 7, we have what? Positive root 7. Then 1 times negative 1 gives us a negative 1. So with all this now, you realize that your negative and positive here goes away. So then I left with just this and then this. So let's see how we are going to simplify further. Simplifying further, we have our numerator remaining as it is, right? So our numerator remains as it is, and then we have 6 root 7 minus 6 all over. Root 7 squared gives us 7. Then we have all of this going off as I said earlier on. So minus 1. 6 root 7 minus 6 all over. 7 minus 1 gives us a 6. Now, per the laws of fraction, we can easily distribute the denominator over both, you see, so that we have 6 root 7 over 6 minus 6 over what? 6. And this one here cancels this. This cancels this. 1 each. So that at the end of it all, we have what? Root 7 minus 1. Very simple and then direct. You see? So this is how we apply the conjugate of sets, and for this matter, binomial sets, to rationalize the denominator. Let's solve one more example just to enhance our understanding. So let's consider this second question here. It says we have to rationalize root of 2 all over root of 6 minus root of 2. So root of 2 over root of 2 of 6 minus root of 2. So we have nothing got to do with the numerator. Our focus is on the denominator, which then affects the numerator. Okay. So root of 2. And as we have always done, we will just have to multiply both the numerator and then the denominator by the conjugate of the denominator. So we have root of 2 times root of 6 plus root of 2. And you know the conjugate is just the opposite sign. All over, we have the root of 6. We are now writing the denominator. And then we'll multiply it by its conjugate. You see? So with this, we now open our brackets. Root of 2 multiplies root of 6 to give us root of 2 times 6 gives us 12. Then root of 2 multiplies root of 2 to give us what? 2. I've told you by now, you should easily be able to what? Evaluate this. Root of 2 times root of 2 gives us root of 2 squared. And root of 2 squared, the 2 here takes out our root sign. Okay. So we now come to the denominator. Root 6 times root 6 gives us a 6. Then root 6 times root 2 gives us a positive root. Let's just say positive root 12. Then negative root 2 times root 6 gives us a negative root 12. Then negative root 2 times root 2 then gives us a negative 2. Okay. So we now do our simplification. So simplifying further, we have root 12. Now, root 12 here, once we are moving ahead, we want to try and do our simplification. So we know root 12 per our simplification, the first video we did. Root 12 is actually root of 4 times 3. Then that gives us 2 root 3. So we have 2 root 3 plus 2 all over 6 minus 2. You see, in writing said it is advisable you bring the number first, most especially if it's even positive. Okay, so we can rewrite it as 2 plus 2 root 3 all over 6 minus 2 gives us a 4. At this stage, we can distribute the 4 to both. So that we have 2 over 4 plus 2 over 4 root 3. All right, which gives us 1 over 2 plus 1 over 2 root 3. Better still, you can write it as 1 plus 1, or just say 1 plus root 3 all over 2. This still holds, right? So this is how we actually simplify or rationalize fractions with rational, or let me say irrational denominators that are binomials. All right. So I'll leave some exercises as I always do, just to test your understanding. So here we have 5 questions you can try on your own just to test your understanding. Let's have beyond numbers where we learn maths the easy way. If there's any issue of concern, you can always let me know at the comment section, and then I'll address that for you. If this is your first time on this channel and you do want to receive notification as to when I release another video, kindly subscribe. And I do hope would learn maths the easy way together. Stay blessed, then see you in our next video. Bye for now.